Welcome to section 5.5.4. Here, we're going to focus on the square root function. And as I stated before in the previous sections, once you understand the rules and patterns or transformation, translation, reflection, and dilation, then identifying transformation for square root will be very easy. So for a square root function, the parent function is going to look like this. F of x equals to the square root of x. Now, if you were to rewrite it with a vertex of 0, 0, then you're just simply going to add in the zeros, which will look like this. F of x equals the square root of x minus 0, and then the plus 0. So that's basically what it's going to look like. And this is going to be helpful when you're identifying vertex for graphing, which will be covered later on or in the later section. So here we're going to focus on translation. What we're going to do is a little review. So let's take a look at our first example. So we have g of x equals the absolute value of x minus 3 and then plus 7. So in this one, it's written in absolute value form. And again, it's going to be the same rules that what we did in the previous section, absolute value, quadratic, and cubic, which will be the same rule for this section, square root function. So here we see that it's a minus 3 inside, so that means that it's going to move right 3 units or translate right 3 units. The plus 7 is outside behind the x, so it's going to translate up 7 because it's a positive 7. So the transformation is translate right 3 units because of the minus 3 behind x and inside the function or inside the absolute value lines. Translate up 7 units because it's a positive 7 or a plus 7 that's outside and behind the absolute value lines. Moving on to example 2, we have h of x equals to the square of x plus 9 and then minus 5. So this equation is written in quadratic form. So just like the same patterns, the same rules, so we're going to look at the plus 9, which is inside behind the x. So since it's plus 9, this one's going to be translated left 9 units. And then the minus 5, it's outside behind the square. So since it's minus 5, meaning that it's going to translate down 5 units. So again, translate left 9 units because of the plus 9 that's inside the parenthesis and behind the x. And then minus 5, translate down 5 units because it's outside and behind the square. So let's take a look at some of the examples applying the rules for translation. So let's take a look at example 3. Example 3 is m of x equals the square root of x minus 3 and then plus 7. So this one is almost identical to example 1. It's just different form. It's written in square root form. So the minus 3 is the same as example 1, and the plus 7 is the same as example 1. It's just that we have square root, but since they're almost identical, meaning similar, just different form, then our answer should be the same. So it should have the same transformation. Translate right 3 units because the minus 3 is inside the square root behind the x. And then translate up 7 units because the plus 7 that's outside the square root or basically behind the square root. So again, similar format, just different form. It should have the same answer if we have the same numbers with the same sign. Now moving on to example 4, we have p of x equals the square root of x plus 9 and then minus 5. So if you look closely, it looks almost identical to example 2. So here we have the plus 9 and the minus 5 in the same location as example 2, just different form for the equation. So since it's almost identical with the same sign of the numbers, then we should have the same answer even though we have a different form for the equation between example 2 and example 3. So our transformation is translate left 9 units because the plus 9 that is inside the square root behind the x, and then translate down 5 units because of the minus 5 that's behind the square root. So, like I said before, just like for example 3, same thing goes for example 4. Since It's a different form, but we do have the same numbers in the same location with the same sign, which should have the same answer compared to example 2. Moving on to example 5, we have a of x equals the square root of x minus 4 and then minus 1. So the minus 4 is inside the square root behind x, so that means that this is going to be translated right 4 units. And then the minus 1, it's behind the square root, so it's going to be, since it's minus 1, translate down 1 unit. So here's the transformation. Translate right 4 units because of the minus 4 inside the square root and behind the x. Translate down 1 unit because of the minus 1 behind the square root. Moving on to example 6, we have b of x equals the square root of x plus 6 and then plus 2. So the plus 6 is inside the square root and behind the x, so this is translate left 6 units. And then the plus 2, it's outside behind the square root, so since it's plus 2, it's going to translate up 2 units. So here's the transformation. Translate left 6 units because of the plus 6 inside the square root and behind the x. And then translate up 2 units because of the plus 2 that's behind the square root. So it's the same rules as what we did for quadratic, for absolute value, for cubic, same thing for square root. So once you memorize the rules, it's going to be easy to identify the translation for any given function, especially for square root.